Friends, welcome to Diamond Group of Institutions, NEET and K-CET online classes. So, yesterday we discussed some problems based on the plane mirror and one problem based on the spherical mirror. Today we are going to discuss both important problems, that means very important problems. Okay, so now I'm going to explain the problem. So, now first problem is this question asked in NEET 2018. The question is an object is placed at a distance of 40 centimeter from a concave mirror of focal length 15 centimeter. If the object is displaced through a distance of 20 centimeter toward the mirror, the displacement of the image will be. This is the question and these are the four options. So now I am dividing this answer into two parts. So in first step, what they given means here, focal length of the concave mirror they given, that is the 15 centimeter. So focal length is the 15 centimeter. So the mirror is the concave mirror. So focal length for the concave mirror is the negative. And the next thing is nothing but the distance of the object is 40 centimeter from the concave mirror. So distance of the object is 40 centimeter from the object. So next what they are doing, they are shifting this object toward the mirror. So you have to remember this word, 20 centimeter toward the mirror. They are shifting 20 centimeter, that is toward the mirror or away from the mirror, that we have to see. So toward the mirror. So actually initially the object is 40 centimeter away from the mirror. Now they are shifting object to 20 centimeter toward the mirror. Then what is the distance between the mirror and the object to 20 centimeter? So next step I wrote here. So that means after shifting the object is 20 centimeter from the mirror. Okay, now I am simplifying here. So focal length given 15 centimeter and initially the object distance is 40 centimeter. So here object is a real object. So u equal to the minus 40 centimeter. The object is real and in front of the reflecting surface. That's why u is, we have to take a maximum. We have to take the u value is negative if the object is real. So now u equal to minus 40 centimeters and focal length of the mirror is minus 15 centimeters. Already yesterday I said to you the image distance. How to find the image distance? By using the mirror formula 1 by v plus 1 by u equal to 1 by f. By simplifying that one, we will get the v equal to uf by u minus f. So I am substituting these values in this formula. So I am getting the first image distance from the mirror. So u value is minus 40, f value is minus 15, u value is minus 40, f value is minus 15. So minus of minus plus 15 I am writing here. Minus into minus plus 40 into 15 by minus 40 plus 15 equal to minus 25. Simplifying, I am getting the minus 24 centimeter. So when the object is at the 40 centimeter from the mirror, it is forming the image at the minus 24 centimeter. So minus 24 centimeter. And in the next step, they shifted the object toward the mirror, shifted the 20 centimeter toward the mirror. So after shifting, the distance between the object and the mirror is the 20 centimeter. So now here the objective distance is the minus 20 centimeters and focal length is the minus 15 centimeter. From this, I am finding the again image distance when the object is at the 20 centimeter from the mirror. So formula is same. I am simplifying and getting the image distance is minus 60 centimeters. That means if the object is at the 40 centimeter, we are getting the image at the minus 25 centimeters. After shifting the object, then we are getting the image at the minus 60 centimeter. Then the displacement of the image is nothing but the final image distance minus initial image distance. So substitute here, final image is at the minus 60 centimeter, initial image is at the minus 24 centimeter. We are getting the image distance is minus 36 centimeter. So here minus 36 centimeter is indicating that. That means one more thing you have to remember in the concave mirror. If the object is moving toward the mirror, the image should be moved away from the mirror up to the focus. That means if the object is moving from the infinity to the focus, then image will be moved from the focus to the infinity. Okay, remember that one. So here the object is moving toward the mirror, so image will move away from the mirror. From that we can cancel here two options. So first option is 36 centimeters toward the mirror. So here image will move away from the mirror. So this is toward is the wrong. And the next one, third option also see now 30 centimeter toward the mirror. This is also wrong. Here we have the two options, 36 centimeter away from the mirror, 30 centimeters away from the mirror. Here we got the 36 centimeters is the right answer, 30 centimeters is the wrong answer. So if the object is moving toward the mirror, image will be moved away from the mirror. How much distance it will move away from the mirror means 36 centimeters move away from the mirror. And the next, based on the similar question, that means this question asked in the NEET 2018, based on the same question in your home assignment, you have one question, that is the question number is the 10th. Home assignment में 10th question is there. Same here they mention one rod they are taking, 10 centimeter length rod they are taking and keeping along the principal axis, 20 centimeter from the pole of the mirror, and focal length of the mirror given 10 centimeters. So same thing here also. What is the distance of the first end from the pole? That means 20 centimeters. So initially that first end ka distance is 20 centimeters. Second end ka distance is this ear to ear distance is the 20 and the length of the object is the 10 centimeters. So second end length is the 30 centimeters. So initially object to length you can consider object to distance is the 30 centimeters, and initially this length distance is the 20 centimeters. Find the image distance of this end and find the image distance of this end, and finally subtract it, you will get the answer. Same way you have to do. And second question. The second question is in the class discussion 20th question in your material class discussion question number 20, that is. The question is a point object is moving with a velocity of 20 meter per second. So here we have the object. They given the diagram also. Here this is the object. Object is moving with the 20 meter per second toward the mirror. So, and it is at the 60 centimeter from the mirror. Okay, the object is 60 centimeter from the mirror and moving towards the mirror with 20 meter per second. Simultaneously, this mirror also moving with the some velocity that is nothing but the 4 meter per second. And they given here radius of curvature of the mirror also they given. Radius of curvature of the mirror equal to 40 centimeter. If they given the radius of curvature, we can find the focal length easily. So focal length equal to the half of the radius of curvature. Okay, next what are they asking means find the velocity of the image relative to the ground. Okay, find the velocity of the image relative to the ground. So yesterday in plane mirror we did the similar problem. Okay, but here it is in the spherical mirror. So for the spherical mirror, the relationship between the image and the object velocities. The formula is dv by dt equal to the minus v square by u square into du by dt. Don't get confused here. dv by dt is nothing but the acceleration something. So that is in the kinematics. Here this v is nothing but the image distance and this u is nothing but the object distance. So dv by dt is nothing but the rate of change of image distance. du by dt is nothing but the rate of change of object distance. So now dv by dt is nothing but the velocity of the image with respect to the mirror, and du by dt is nothing but the velocity of the object with respect to the mirror. This is the formula we will use. And next, whatever the given data I am writing here, the given object velocity is 20 meter per second. Here I am not taking the unit vector. Why? Because both are moving in the single axis only along the x-axis, and both are moving in the same direction, and not considering the unit vectors. So now the velocity, both are moving in the positive x direction. So positive x direction I am considering as a positive only. So now velocity of the object is given 20 meter per second. Velocity of the mirror is given 4 meter per second. And initially object is 60 centimeter from the mirror. So object distance u equal to minus 60 centimeter. And they given the radius of curvature 40 centimeter. From that we can find the focal length equal to the half of the radius of curvature. That is 40 by 2 equal to the 20. The focal length for the concave mirror is the negative. Radius of curvature also negative. Okay, so f equal to minus 20 centimeters. Okay, and next to get that one, so here we have the formula velocity of the image with respect to the mirror equal to the minus v by u whole square velocity of the object with respect to the mirror. I am expanding this one. So velocity of the image with respect to the mirror is nothing but the vi minus vm equal to minus v by u whole square into velocity of the object with respect to the mirror is vo minus vm. So now here we have to find the velocity of the image. So velocity of the image we have to find. To find velocity of the image vm, velocity of the mirror we know, v value we don't know, and u value we know, and velocity of the object we know, velocity of the mirror we know. So we have to find the v value. How to find the v? V means v is nothing but the image distance. Image distance formula already we know. That is v equal to u into f by u minus f. U value is a minus 60, f value is a minus 20, and u value minus 60, minus into minus plus 20. So here minus into minus plus 60 into 20 by minus 60 plus 20 is nothing but minus 40. Simplify it, you will get the minus 30 centimeters. So image distance is the minus 30 centimeters. So substitute all these values in this formula. Velocity of the image minus velocity of the mirror is nothing but already given 4 meter per second equal to minus v by u. V value is a minus 30 by u value is a minus 60 whole square into velocity of the object is 20 meter per second. 20 minus velocity of the mirror is 4 meter per second. I substituted here values. Simplify it. Here 31 and 32. 1 by 2 whole square is nothing but 1 by 4. 20 minus 4 is nothing but 16. Now simplify it. We will get the Vi minus 4 equal to minus 4. Minus 4 sign, that side it will become plus 4, and Vi equal to 0 meter per second. So with the velocity of the image relative to the ground equal to the 0 meter per second, the option C is the right option. The next problem is, so this question is in your home assignment 8th question, and one time in 2009 medical exam they asked this question. The question is, a transparent solid cylindrical rod has a refractive index of 2 by root 3. It is surrounded by 8. A light ray is incident at the midpoint of one end of the rod as shown in the figure. So made here incidenting. Okay, the incident angle theta for which the light ray grazes along the wall of the rod. So what is the angle? This one we have to find. For which angle this ray grazes along the wall of the rod. We have to find. So given options are A, B, C, D, these options given. So before going to solve this problem, just remember this one. That means if a ray is entering from the one medium to the other medium, that means here the interface is the transparent. So now if the ray is entering from one medium to the other medium, these two mediums have the two different refractive indexes. Depending on the refractive indexes, the ray will be deviate from its original path. How it will be deviate means, if this so first medium ka refractive index is mu1 and this medium ka refractive index is mu2. Suppose we are assuming that mu1 is greater than mu2. That means this medium is a denser medium and this medium is a rarer medium. If the ray is moving from the denser medium to the rarer medium, it will move away from the normal. Okay, now so actually ray has to go in this direction. So now it is entering from denser to the rarer, it will move away from the normal. So now at this point, in this case, we have to apply the Snell's law. How to apply the Snell's law? See now. So refractive index of this medium into sine of angle in that medium only. So refractive index of that medium mu1 and the sine of angle in that medium is I equal to the refractive index of this medium mu2 into sine of angle in this medium is the sine r. So from this we will get sine I by sine r equal to mu2 by 1. This is nothing but the Snell's law. Okay. So mu is nothing but the refractive index of mu2 1 means refractive index of the second medium with respect to the first medium. So by using this one we are solving this problem. So first to see now, this ray is striking the midpoint of the rod here by making some angle theta. Now entering into the rod. Okay, the rod is the transparent solid cylindrical rod. Now entered, and next for which angle of this incident angle, here the ray will be grazes along the wall of the rod, that we have to find. So now here the angle equal to here it is incidenting with some angle, that is the I, and now here the angle equal to the 90 degrees. For definition, you have to remember that when the ray is entering from the denser medium to the rarer medium, so cylindrical has the refractive index is 2 by root 3, and here the surrounding medium is the 8, that has the refractive index is the 1. So when the ray is entering from the denser medium to the rarer medium, so one particular angle, the refracted ray will be grazes along the interface. That angle of incident is called as the critical angle. So if the angle of incident is equal to the critical angle, then the refracted ray will be grazes along the wall of the rod. So now here the angle of incident is nothing but the critical angle, and next here the refracted angle of refraction is nothing but the 90 degrees. Now at this point, at the A point, I am applying the Snell's law. So this is the one medium and this is the one more medium. This wall of the cylindrical rod is separating these two mediums. Now I am applying the Snell's law here. So refractive index of this medium into angle in that medium, sine of angle in that medium. So mu2 into sine IC equal to this medium. Refractive index of this medium is nothing but air is surrounded by this cylinder. So mu1 into angle in that medium is the sine 90. So now mu2 sine IC equal to mu1 value. So the surrounded medium is the 8. The refractive index of the air is the 1, and sine 90 value is 1. We will get mu2 into sine IC equal to 1, and sine IC equal to 1 by mu2 equal to root 3 by 2. So mu value they given, mu value equal to how much they given, 2 by root 3. So here 1 by mu2 is there, then we will get the root 3 by 2, and sine IC equal to the, so in sine term when will we get the root 3 by 2 means 60 degrees, so IC equal to the 60 degrees. So instead of doing all these steps, we can do directly this step also. If the surrounding medium is 8, then actually the critical angle formula sin IC equal to the refractive index of the ratio of refractive index of the rarer medium to the refractive index of the denser medium. This is the formula, direct formula. But here surrounded medium is the air, so the rarer medium is the air. So the refractive index of the air equal to 1. Direct we can write sin IC equal to the 1 by mu. So to get that one, I explained this one. Directly you can use the this formula and substitute the u value. You will get the critical angle 60 degrees. So now here we got the 60 degrees. So suppose consider this is the A, and now extend this normal up to the axis of the cylinder. So here it is striking B point, and next here it is the C point. Now here it is making the 90 degrees. So critical angle is 60 degrees, and next here it is the 90 degrees, and this is considered A B C triangle. So sum of three angles equal to the 180 degrees. So this is the 60, this is the 90, 150 degrees. So then what is the R value? 30 degrees. So directly we will get the 30 degrees. R value is 30 degrees. Again, at the C point, apply the Snell's law. That means refractive index in this medium into sine of angle in that medium equal to the refractive index of this medium and sine of angle in that medium. So mu1 sine theta equal to mu2 sine R. So mu1 is the nothing but the air ka refractive index 1, sine theta equal to mu2 value is the refractive index of cylinder 2 by root 3 into sine R value we got 30 degrees. Substitute here, we will get the sine theta equal to the 2 by root 3 into sine 30 value is the 1 by 2. Simplify it, we will get the sine theta equal to 1 by root 3 and theta equal to sine inverse of 1 by root 3. The answer is sine inverse of 1 by root 3. D option is the right answer. You have to do in this way. So one time this question asked in 2009 medicine exam. And next to come to the fourth question. This question in your material home assignment by 19th question. So the question is, a light beam is traveling from a region 1 to region 4. Here they given the diagram also. So region 1, 2, 3, 4. The ray is entering from region 1 to the 4. So now they given the refractive indices in the region 4 regions ka refractive indices given. Region 1 ka mu naught, region 2 ka mu naught by 2, 3 ka mu naught by 6, 4 ka mu naught by 8. That means refractive index is decreasing gradually. That means so first medium is a compare with the second, first one is a denser, compare with the third one, second is a denser, compare with the fourth one, third one is a denser. Okay, now they are asking the angle of incident theta for which the beam just misses entering region 4. So that means here this is the what for which angle of incident the ray should not enter the fourth medium. That means it grazes the interface of the third and fourth regions we have to find. So now see the diagram. I redrawn the diagram here. See now. So first region, second region, third region, fourth region. So here the angle of incident equal to theta. Now the ray enter into the second region. So here the ray is entering from the denser to the rarer. It will move away from the normal, just bend more. So now this here these two layers are parallel to each other. So either ear angle is same theta 1 and theta 1 only. And the next again denser to the rarer, again it will bend more and reach to here. So every time the angle of incident is increasing. So at particular angle, so here at theta 2, this ray is not entering into the fourth region, just it is grazing the interface of the third and fourth region. To graze the refracted ray along the interface of third and fourth region, what is the angle of the incident? That we have to find. So here also we have to apply the Snell's law at each and every region. Suppose I am applying the Snell's law in between the first region and second region. So here mu naught sine theta equal to the here refractive index mu naught by 2. Here angle is theta 1. So mu naught by 2 sine theta 1. So now apply the Snell's law second and third region. So here angle is theta 1. So mu naught by 2 sine theta 1 equal to either refractive index is mu naught by 6. Here sine of angle is theta 2. So sine theta 2. So apply the Snell's law at the third and fourth also. Third ka refractive index mu naught by 6 and sine of angle here is the theta 2. So theta 2 equal to here the refractive index is mu naught by 8. Sine of angle here is the 90 degrees. Now equate this term. Mu naught sine theta equal to mu naught by 2 sine theta 1. This mu naught by 2 sine theta 1 also equal to the mu naught by 6 sine theta 2. Mu naught by 2 sine theta 1 also equal to mu naught by 6 sine theta 2. This mu naught by 6 sine theta 2 is also equal to mu naught by 8 sine 90 degrees. Sine 90. So in exam directly you have to use this step only. You are going to write exam. You have to save the time. Okay, you have to do this problem within the 20 or 30 seconds only. You don't have the more time. So then don't do these steps just to to get easily. I explain this one, but don't do this one directly. You can do this step. That means if the light is passing through a series of parallel layers with a different mediums, then we can write the formula mu sin theta equal to the constant. That means here we can equate all this. So mu naught sin theta equal to the, so refractive index of mu naught by 2, here angle is theta 1, so here the mu naught by 6, here angle is the theta 2, here refractive index mu naught by 8, here angle is the 9. Equate it. So from this, what we have to find, angle of incident we have to find. To find the angle of incident, direct compare the first and the last terms. So mu naught sin theta equal to mu naught by 8 sin 90. So mu naught will be cancelled. So sin theta equal to the 1 by 8 into sin 90 value is the 1. So theta equal to sin inverse of 1 by 8. So now answer is the sin inverse of 1 by 8. Like this you have to do the problem. Next problem, fifth problem. In your material class discussion, my 18th question this one. In some other competitive exam in 2018 they asked this one. Okay, the question is a bubble in a glass slab. A bubble in a glass slab. The refractive index of the glass slab is 1.5. When viewed from one side appears at 5 centimeter and appears at 2 centimeter from the other side, then thickness of the slab is. Okay, these are the options. Now see, this is the glass slab now. Glass slab ka refractive index is mu equal to the 1.5. Okay, now here we have the bubble. Okay, so actual distance of the bubble from this end is x and actual distance of bubble from this end is the y, and we are weaving from this end and this end. If you are weaving from this end, this is appearing at 5 centimeters. If you are weaving from this end, this appear at 2 centimeters. Okay, before going to solve this problem, once you see the concept. Okay, in that concept, suppose the object is in the denser medium and we are viewing this object from the rarer medium. Okay, object is in the denser medium, we are viewing from the rarer medium, then the depth of the object appear less than the actual depth. That means here this is the actual depth. Now shift to here. Okay, now so now if the object is in the denser, we are viewing from the rarer medium, then the object appear as less than the actual depth. That means the apparent depth is less than the real depth. So from this we can write down, so if the apparent depth is less than the real depth, so then we have to do the division. So apparent depth equal to the real depth by the refractive index of the denser medium. So from this we can write real depth equal to the mu into apparent depth. So next case, the object is in the rarer medium and we are viewing from the denser medium. If we view the object from the denser medium to the rarer medium, then object appears more than the actually from here to the actual depth, it will appears more than the actual depth. So apparent depth is more than the real depth. So if you are viewing the object from the denser medium to the rarer medium, apparent depth is greater than the real depth. So then the formula is apparent depth equal to the mu into real depth. So here apparent, in this case, if you are viewing from the rarer to the denser, apparent depth is less than the real depth. That's why apparent depth equal real depth by mu. Here we are doing the division, and in this case we are viewing from the denser medium to the rarer medium. Apparent depth is greater than the real depth. That's why here we are multiplying the refractive index into the real depth. Then AD equal to mu into refractive real depth. So by using this concept, we are solving this problem. So this is the glass slab. Glass slab ka refractive index is 1.5 and the surrounded by the glass slab is the 8 and the refractive index of that one is the 1. So glass slab is the denser medium and we are viewing from the rarer medium. In this cases which is applicable, so first one is the object is in the denser and viewing from the rarer. So object is in the denser, viewing from the rarer. So first condition is applicable. From that, apparent depth equal to the real depth by mu, or real depth equal to the mu into apparent depth. Mu is the refractive index of the denser medium. So use this formula. So here I am using that formula. So in the first case, apparent depth equal to how much? 5 centimeter. What is the actual depth of 5? So in first side, from here I am viewing. So apparent depth equal to 5 centimeter, but actually depth equal to the real depth equal to the x. So from this case, I am using the formula real depth equal to mu into apparent depth. So real depth equal to mu into apparent depth. So I am substituting here. Real depth is nothing but the x equal to mu value of the glass. Refractive index of the glass is 1.5 into apparent. How much it is appearing? 5 centimeters. So substitute, we will get the x equal to 7.5 centimeters. And the next case, second, we are viewing from the second end. So that time actual depth is the y. That means real depth equal to the y. So AD is nothing but the apparent depth. Apparent depth, how much it is appearing? 2 centimeters. So apparent depth equal to the 2 centimeters. So from this formula we are writing here. So real depth equal to the mu into apparent depth. Real depth is the y, mu value is the 1.5, apparent depth equal to the 2. From this we will get the y equal to the 3 centimeters. So x is the actual depth from the one end to the bubble, and y is the actual distance of the bubble from the other end. So total thickness of the glass slab T equal to the x plus y. Then we will get the 10.5 centimeter. The answer is 10.5 centimeter is the right answer. Instead of doing all this, we can do the short, we can do the easy way also. That is nothing but if you are seeing one from one side it is visible as a 5 centimeter, other side it is appearing as a 2 centimeters. So total real depth equal to the mu into total apparent depth. So real depth is the T, and mu is nothing but the 1.5, and the total apparent depth, one side 5 centimeter and other side is the 2 centimeters. That is nothing but the 5 plus 2, 7, 7 into 1.5 is 10.5 centimeters. You can use this short trick, otherwise you can follow this way. And next, see the next question, sixth question. The question is, light takes t1 second to travel a distance x in vacuum, and the same light takes t2 second to travel 10x centimeter in a medium. So find the critical angle for corresponding medium will be. What is the critical angle? We have to find. So here in the first case, the light is traveling in the vacuum. In the vacuum, the speed of the light c equal to the distance upon the time. Already you know the speed formula. Speed equal to the distance upon time. So in the vacuum, the speed of the light symbol is c equal to the distance is the x and the time taking t1. And in the medium, the speed traveled by the light ray, we are assuming here b equal to how much distance it traveled to 10x, how much time it took t2. So v equal to 10x by t2. So they are asking the critical angle. Already in the previous problem we discussed critical angle sin IC equal to the refractive index of the rarer medium to the refractive index of the denser medium. And one more thing here you have to remember that refractive index is inversely proportional to the speed of the light and inversely proportional to the wavelength of the light. By using the condition, here we are solving the problem. So sin IC equal to ratio of refractive index of the rarer medium to the refractive index of denser medium. So refractive index is inversely proportional to the speed. So now here I am writing, so this is the ratio of the refractive index of rarer medium to the denser medium. Here we will get the speed of the light in denser medium to the rarer, Vd by Vr. Here denser medium is nothing but the medium and rarer medium is nothing but the vacuum. Medium में velocity is v and vacuum में velocity is c. So sin IC equal to v by c, and sin IC equal to v value we know already 10x by t2, 10x by t2, and c value already we know x by t1, and do the simplification and we will get sin IC equal to 10 t1 by t2 and IC equal to sin inverse of 10 t1 by t2. IC is the critical angle. The option is C option is the right answer. So like this way we have to solve the problems. So this is the in your material class discussion with ninth question. So students listen carefully. Actually you have to do the each question in the competitive exam 30 seconds to 1 minute only. So you have to do the speed. Okay, set your brain to do the problem fast. Okay, so now see the question is the refractive index of material of equilateral prism is √3. Then angle of minimum deviation of the prism is. Here they mention equilateral triangle. So equilateral triangle means each angle equal to the 60 degrees only. So now here the angle of prism, that means this is the prism. So angle of prism, this is also called as the refracting angle. That angle equal to the 60 degrees. So A equal to 60 degrees, and the refractive index also they mentioned mu equal to the √3. So now we know the if the prism is in the minimum deviation condition, then refractive index formula is mu equal to sin A plus d minimum by 2 by sin of A by 2. This formula. Substitute the values here, refractive index value and angular prism value. So then we will get √3 into sin 60 by 2 is nothing but the 30 value. I am sending this side, sin 30 equal to sin 60 plus d by 2. √3 into sin 30 value 1 by 2, sin 60 plus d by 2. So this value is the √3 by 2. There is nothing but sin 60. Now equate the angles. By simplification we will get the minimum deviation equal to the 60 degrees. So we can solve this problem very easily by using the formula. And one more condition is if the triangle is isosceles triangle or equilateral triangle, in the minimum deviation time, the refracted ray in the prism is parallel to the base of the prism. Remember that one. And in the general cases, the deviation formula for the prism is D equal to I plus E minus of R1 plus R2. Here I is the angle of incident, E is the angle of emergent R1 is the here at the first surface refracting angle, and R2 is the secondary refracting angle. Okay, now so here next one more formula is angle of prism equal to the R1 plus R2, and for minimum deviation condition angle of incident equal to the angle of emergent I equal to E, and R1 equal to the R2. So then I'm substituting here, then I will get the D equal to 2I minus A, or A equal to the R by 2. So set your brain to do the fast these problems. Okay, and next question is the in your material home assignment में 21 problem. The question is a thin prism of angle 15 degrees made up of glass of refractive index 1.5 is combined with the another prism of glass of refractive index 1.75. The combination of the prism produces a dispersion without a deviation. The angle of the second prism should be. So here these two prisms are arranged in this way. एक prism का angle of prism they given 15 degrees, and refractive index of this prism is 1.5, and one more prism angle of prism we have to find the this prism ka refractive index is 1.75. So here the condition is they combine this prism such a way dispersion without deviation. Without deviation means the deviation produced by this prism is cancelled. The mean deviation produced by first prism cancel out by the mean deviation produced by the second prism. That means the mean deviation is parallel to the extended incident ray. So here it is parallel. That's why we can say it as a dispersion without deviation. Here we are not getting any. The mean deviation ray is parallel to the actual incident ray. Okay, so now the deviation produced by the first prism is cancelled by the second prism, we are saying. So the deviation produced by the first prism is the D, and the deviation produced by the second prism is the D dash. So cancel. That means both are same. So deviation formula is, so for a small angle prisms, small refracting angle prism, deviation formula is D equal to A into mu minus 1. This formula I am using here. So D equal to A into mu minus 1. For second prism, deviation is A dash into mu dash minus 1. Here I am substituting the values. That means first prism ka angular prism given, refractive index given, and second prism ka refractive index given, angular prism we have to find. Substitute the values. So from this formula, A dash equal to the A into mu minus 1. This mu dash minus 1 send this side. So we will get A into mu minus 1 by mu dash minus 1. Substitute the values and simplify. We will get the second prism ka angle, refracting angle is 10 degrees. Along with this, you have to remember the two more formulas. Angular dispersion ka formula is nothing but dV minus dy. How much that dispersion is there between the violet color and red color. So use this formula. And the next to dispersive power formula also remember, dispersive power equal to this AD by MD means angular dispersion by mean deviation. So angular dispersion is nothing but dV minus dy by mean deviation is nothing but the dy. Actually in VCR colors, VCR may actually we will consider the violet color is the mean color. So here we will take the mean deviation with the violet yellow color. So mean color we consider as the yellow color. So mean deviation we will consider the yellow color. So this is the formula you have to remember. Okay, next question. In your material class discussion mein first question. Okay, the question is, in order to obtain a real image of magnification 2 using a converging lens of focal length 20 centimeter, where should an object be placed? So here they given the converging lens. Converging lens is nothing but the convex lens. So for the convex lens, and the next they mention here the image is the real image. So magnification equal to the minus, and the value given 2. For real image magnification is the minus. Okay, m equal to minus 2, and the focal length of the converging lens they given 20 centimeter. For converging lens, the focal length is the positive, f equal to plus 20 centimeter. They are asking the object distance, where we have to keep the object to get the real image, and the magnification is the 2. So now before going to solve this problem, I am giving the some formulas. Length formula is nothing but the 1 by v minus 1 by u equal to 1 by f. By simplifying this one, we will get the p equal to u into f by u plus f. And the next here transverse magnification formula, already in the mirrors we discussed. Same way here also, ratio of height of image to the height of the object. And the next here ratio of the image distance to the object distance. In the mirrors we have the minus v by u, in the lenses we have the v by u. And the next here formula is f by f plus u. There we have the f by f minus u in the mirror. So remember this formula, don't get the confusion here. So magnification formula is hi by ho or v by u or f by f plus u. Depending on the situation, given data, we have to use the formula. Now I am using here magnification given us, so m equal to, and the next focal length given, they are asking the objective distance. So this one is the suitable here. M equal to F by F plus U. So here I take the M equal to F by F plus U formula I took here, and I am substitute the values. M value is -2 and F value is plus 20, and simplifying after that, doing the simplification step by step, I got the objective distance is minus 30 centimeters. So answer is the minus 30 centimeters. Okay, the next question. In your material class work mein, fifth question. The question is focal length of a convex lens of refractive index 1.5 is 2 centimeter. Focal length of lens when immersed in liquid of refractive index of 1.25 will be. If here initially not mention any medium means we have to consider that is the air. So whenever the converging lens, the convex lens is in the air, the focal length is the 2 centimeters, and the refractive index of the lens equal to the lens is made up by the glass. That's why I consider here refractive index of the glass equal to the 1.5. And we are immersing, we are keeping this convex lens in the water. Then water ka refractive index is given, liquid ka refract, not water, liquid, any liquid. Liquid ka refractive index is 1.25. Whenever we immerse this convex lens in the liquid, what is the focal length they are asking. So to get this one, we have to use the formula. That formula is lens maker's formula. So formula is 1 by F equal to mu minus 1 into 1 by R1 minus 1 by R2. Use this formula. So whenever the convex lens is in the air, so now 1 by FA equal to this mu minus 1 we are writing now. This mu is nothing but the refractive index of the lens with respect to the medium. Okay, refractive index of the lens with respect to the medium. So here first case the convex lens is in the air. So refractive index of the lens with respect to the air into 1 by R1 minus 1 by R2. And in this case the lens is in the liquid. So here 1 by FL equal to the here the refractive index of the lens with respect to the liquid. G means glass, lens made up by the glass. And here L means liquid. So refractive index of the lens with respect to the liquid minus 1 into 1 by R1 minus 1 by R2. These are the two equations we got. I am doing the 1 divided by the 2, then I will get 1 by FA by 1 by FL equal to. Suppose if I divide the 1 by 2, then these two terms will be cancelled out, and the remaining term, this 2 I will get. So here mu GA minus 1 by mu GL minus 1. So here if we do the simplification, we will get FL by FA equal to this mu GA is nothing but the refractive index of the lens with respect to the air. Refractive index of the lens with respect to the air minus 1 by downside in the denominator we have refractive index of the lens with respect to the liquid. Refractive index of the lens with respect to the liquid minus 1. Substitute the values. So the given already refractive index of the lens is nothing but the 1.5, and air ka refractive index is 1, we know already, and here also refractive index of the lens is 1.5, and refractive index of the liquid also the given 1.25. Substitute the values and do the simplification step by step. You will get the focal length in the liquid is the 5 centimeters. Here already they mentioned focal length in the air is the 2 centimeters. So in the whenever we keep the convex lens in the liquid which has the refractive index 1.25, then the focal length of the convex lens will be increased to, that means 5 centimeters. Focal length equal to the 5 centimeters. Okay, see students, so actually in 180 bits we have to do in the 3 hours only. So do the all the bits very fast. We have to complete each and every bit within the 30 seconds only. So do it fast, habituate to do the problems fast.